Hey YouTube, welcome back. Today we'll talk. This is the last video in our series Design a Chat System. Today we will make a wrap up of the full design. So, if you didn't watch the previous videos, I hope that you watch them because you'll understand everything in details. Because today's video I will only go on the high level design of what we designed. So, when it comes to system design interviews, we said before that designing the system interviews start with a pretty vague question. It's an open-ended question like design Facebook, design WhatsApp, design a chat system, design whatever. And our job as an interviewee is to make sure that we are asking the right questions to um, to to understand the problem and establish the design scope that exactly our interviewer wants us to design. And we said that we do this one by following, we succeed in this type of interviews by following this framework. First of all, we have to understand, we should understand the problem. And we do this by asking some specific questions. So we have 5 types of questions, like for example, what kind of app that we're working on. We ask about is it for mobile or desktop. We ask about how the functionality, how the app function, and this one could be 4 or 5 questions that you can ask about the functionality. We talk about how scalable the app is. For example, if our application is built on users activities, so we'll say how many daily active users that we have. We also ask about the CAP theorem, which is the consistency, availability, and the partition tolerance, and do we prefer to our application to be more consistent or more available? And by these questions, we will understand the requirements and the functional requirements and non-functional requirements. Basically, we will understand the requirements of our system. And after that, after going into finishing the first step, we just try to propose a high-level design. And in the proposal high-level design, we talked about the protocol that we can use, and we talked about that we have an HTTP protocol that has sender and receiver, and the sender send like a client sends something to the receiver, but the receiver take it a response. So what we have here, the sender send it to the chat service, as we said before, that this could be an HTTP. But however, how the receiver will know that the chat service has a new message for them. So with it that we can use polling or long polling with HTTP, or we can use an WebSocket. So the WebSocket, if you don't know what is a WebSocket, the WebSocket, it is WebSockets are communications protocol that enables two-way communication between client, usually a web browser or like mobile, and server over a single long-lived connection. Unlike the traditional request-response model on HTTP, where the client sends a request and the server responds with a single response, WebSockets allow for ongoing communication in both directions. So because of that, we said that we use WebSockets to make sure that we have both direction, and because this is the best thing rather than the polling or long polling. And after that, we continue our journey in the high level design, and we just talk about the stateless tier, and we said that the stateless sometimes it doesn't I'm trying to do it with the mouse, but it doesn't want. It's weird. Okay, so we talked about the stateless tier, and the stateless service are traditional public-facing request-response services, because we will not use WebSocket everywhere. We have some stateless that are using HTTP request response type of way, and with this used to manage the login, sign up, user profile, etc. And these are common feature among the website app. The stateless, as we said before, the stateless services sit behind a load balancer, whose job is route requests to the correct services based on the request path. The services can be monolith or individual microservices. We do not need to build many of these stateless services by ourselves, as there are services in the market that can integrate it easily. The one service that we will discuss more, it will be the service discovery, and this come in a bit. After that, we talked about the stateful service, and this is a stateful service. The only stateful service in the is a chat service. The service is stateful because each client maintain a preset network connection to a chat server. In this service, a client normally does not switch to another chat server as long as the server is still available. The service discovery that we will talk about it in a bit, coordinate closely with the chat service to avoid any server overloading. After that, we have third party, and the main third party, it will be our notification. So for the chat app, push notification is the most important third party integration. It is a way to inform users when new messages have arrived, even when the app is not running proper. It's not running, and the proper integration of push notification is crucial, and it's one of the most important thing. And we have a serious talking about notification. I highly recommend you to watch it. So after that, we talked about the scalability. And when we talked about the scalability, we said that on small scale, all services listed above could fit in one server, even at the scale we designed for. It is in theory possible to fit all user connections in one modern cloud server. The number of concurrent connections that the server handle will most likely be limiting factor. In our session at 1 million concurrent users, assuming each user connection needs 10k of memory on the server, this is very rough figure. It's only need a 10 gigabyte of memory to hold all connections on one box. However, if we propose a design where everything fits in one server, this may raise a red flag in the interviewer's mind, because no good technologists would design such a scale in a single server. So single server design is ideal. It's a deal breaker due to many factors. One of the main things is a single point of failure. So because of that, we created a distributed system instead of have one single server. So however, it's perfectly fine to start with a single server, as we said before. Just make sure that the interviewer knows this is the starting point, putting in everything we mentioned together. So we have here the chat servers facilitate messages sending and receiver, and we have the pre-seen server manage online and offline status. The API services handle everything, including user login, sign up, and change profile. We have the notification servers, such they are send push notifications. And finally, we have a key value store. A key value store is used to store the chat history. When an offline user comes online, she or he will see all previous chat. And we have the load balancer, and to distribute all the requests, the incoming requests to the servers. So after that, we talked about the storage. And in the storage, we said that at this point, we have servers ready and servers up running and third-party integrations. And to complete all of that, deep down, the technical stack is in the data layer. So data layer usually requires some effort to get it correct. An important decision we must make sure that we are taking is using SQL or NoSQL databases. And sorry. And we said that And to make an informed decision, we will examine the data types and in the read and write. So two types of data exist in the typical chat system. The first is generic data such as user profile, setting, user friend, and list, and etc. These are sorted in a robust and reliable relation database. Replications and sharding are common techniques to satisfy availability and scalability requirements. The second is unique to chat system because the chat history data, it is important to understand the read and write pattern. So the, the amount of data is enormous for a chat system. So, and the other thing, that only recent chats are accessed frequently. User do not usually look up to for the old chats. Although third thing, although very recent chat is viewed in most cases, users might use features that requires a random access of data, such as search. So view your mentions, jump to a specific message, etc. These cases should be supported by the data access layer. The read and write ratio, I guess, it will be 1:1. So from selecting and from all of this one, we should know that selecting the storage system that supports all of our cases is crucial. And we said that we recommend key value stores for the following reasons. And we said that before, the key value stores allow users horizontal scaling. Key value stores provide very low latency to access data. Relational databases do not handle long tail. And we said about that what is and if you don't know, because I guess a lot of you doesn't know what is a long tail. The long tail refers to statistical distribution where a high number of occurrences or observations are found in the tail end of the distribution curve, as opposed to the more concurrent head or main section. Um, in 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 um, in database perspective, in database perspective, in context of database, the and data analysis, long tail refers to distribution pattern where a large number of items have relatively low frequency or occurrences, while a smaller number of items have high frequencies. This distribution is often depicted graphical as a curve that it starts high and gradually tapers into a long tail. Also, key value stores are adopted by other proven reliable chat applications. For example, we have Facebook Messenger and Discord also using key value stores. And after that, we talked about the data models. We talked about how we build our data models for the chat system, and we said that the message ID, it will be we have the message ID, it will be an integer. We have the message from, it will be the user ID from. The message ID 2, it will be also a big integer, and we have the content will be text, and create that will be a timestamp. And this is for the one-on-one, and we have the one for group. We have the channel ID, and we have the message ID and the user ID and the content and the created ad. And after that, we talked about the message ID and how to generate the message ID is, and we talked about the Twitter Snowflake is the best way to use to create the message ID. However, the final approach is to use the local sequence number generated locally. Means the IDs are only unique within a group. The reason why local IDs work is the maintaining messages sequence with one-on-one channel or group channel is sufficient, and this approach is easier to implement as the Twitter Snowflake. And after that, we start the deep dive, and we talked about the service discovery. And we said that the primary role of the service discovery is to recommend the best server for the client based on the criteria like geography, location, server capacity, um, etc. And we said that we can use Apache Zookeeper because it's a popular open source solution for service discovery, and it registers all the available chat servers and picks the best chat server for client based on a predefined criteria. And we said that we have, from this diagram, the user tries to log in into the app. The load balancer sends the login request to the app servers. After the backend authenticates the user, the service discovery finds the best chat server for user A in the example that you can see. And we have user A, or like this user, connects to the chat server 2 through a WebSocket. We talked about the message flow, and we said that it is interesting to understand the end-to-end flow of the chat system. In this session, we will explore the message flow in one-to-one. So basically, what happened here? We have user A. User A sends a chat message to the chat server 1. The chat server 1 obtains a message ID from the ID generator, as you can see. The chat server 1 sends a message to the message sync queue. The message sync queue is sorted in a key value store. And we said that in number 5, there's two things happen. If user B is online, the message is forwarded to the chat server 2, where the user B is connected. B, if user B is offline, a push notification is sent from push notification. This one is called push notification servers, and when the user become online again, we send it again. The chat server 2 forward the message to user B. There is a persistent WebSocket connection between user B and the chat server 2. And after that, we talked about the message synchronization across multiple servers, and we said that many users have multiple devices. We will explain how to sync messages across multiple devices. So as you can see here in this one, user A has two devices, a phone and a laptop. And when user A logs into the chat app with her or his phone, it establishes a WebSocket connection with a chat server. We have a chat server 1. Similarly, there is a connection between the laptop and the chat server 1 also. Each device maintains a variable called current makes message ID, this one. And the current makes message ID the current makes message ID, which keeps track of the last message ID on the device. Messages that satisfy the following two conditions are considered as new messages. For one is the I all the time mispronounce this type. Let me just try to pronounce it in the right way. Recipient. Yeah.
Recipient.
No, not recipient. Recipient.
Recipient.
No, it's not recipient. It's recipient. No, there is no O here. There is no O.
Recipient.
Yeah, recipient. Yeah, recipient. Okay. So the two conditions are satisfied to condition to consider this message as new message. The recipient ID is equally to the current login user ID. The message ID in the key value store is larger than the current makes message ID. With distance, current makes message ID on each device. Message synchronization is easy as each device can get new messages from the key value store. And after that, we talk about the chat flow, and we say that let's explain what happens when user A sends a message in a chat group chat. Assume that user we have 3 members in the group. and we said that user A and user B and user C, and we said that first the message from user A is copied to each group members message sequence queue, one for user B. We have one for user B and one for user C, but this is the old one. This is the new one. This is different gram. This is the end gram, and we said that if we did like that, this will not work. So we said that what we can do is that we will create a one message queue to satisfy all users. So like the message, because if we create a message queue for each user, that means one message means like one event for each user, and we have a big group. That means we will have a bottleneck. So we have a one message queue. When the user A sends the messages to the message queue, the message queue will send the messages to user B and user the chat server. It will send it to the chat server. After that, user B and user C can see it. And after that, we talked about how we will deal with the online pre-scene, and we said that an online pre-scenes indicates it is an essential feature of many chat applications. Usually, you can see a green dot next to the user's profile picture or username. Also, so in high-level design, a pre-scene server are responsible for managing. Managing online status and communicating with clients through WebSockets. Oh, okay, sorry. And we said that there are a few follows that will trigger the online status, and let's talk about how they will use. For example, we have a user login and user logout, and we see that the user login flow is explained before that in the service discovery. After a WebSocket connection is built between the client and the real-time service, user A, for example, we have this user, let's call it user A. User A online status will be status and last active at timestamp are saved in the key value store. The pre-scene indicator shows the user is as online in the logs. We have the user logout. When the user log out, it goes through such a logout flow to as you can see here. The online status change into offline in the key value store. And the pre-scene indicator shows the user as offline. And we have other thing, the user disconnection. And we said that we all wish our internet to be our internet connection is considered as reliable. However, that is not always the case. Thus, we must must address this issue in our diagram. When a user disconnects from the internet, the present connection between the client and the server is lost. So a naive way to handle this user disconnections, we said that it is to mark user as offline and change the online. And when connection re-established again, we do an online. However, this approach has a major flaw. It's common for users to disconnect and reconnect frequently in a short time. For example, network connection can be on and off while user goes through a tunnel. And we said that updating online status on every disconnection and reconnect would make the pre-scene indicator change too often, resulting a poor user experience. And we said that we introduce a heartbreak mechanism to solve this problem. Periodically, an online client sends a heartbeat event to pre-scene servers. If the pre-scene servers receive a heartbeat event within a certain time, say X seconds, for example, from the client, the user considered as online. Otherwise, it's considered an offline. So, for example, we have here every 5 seconds, the client should send a heartbeat to the servers. So after each for example, that we require 3 heartbeats to consider the client offline or online. So after 3, he is online, and maybe the user doesn't send anything again, so the user is offline again. And after that, we talked about how to work with the online status fan out, and we said that how do users know about the status changes. So you are offline right now. So how the users know that you are offline? So in this one, we explain how it works. The present servers use a publish subscribe model in which each friend pair maintains a channel. When user or user one online status changes, it publish the event to 3 channels. The channels for these users, and the channels are subscribed, and those channels are subscribed by user 2 and 3 and 4, and thus it's easy for friend to get online status and update. And yeah, that's it. And this was the last thing in our chat system. And I hope this series was quite good for you, and I hope that you learned from it. And yeah, if you like my content, make sure to subscribe and hit the notification bell so you never miss a video. And let's wait for the next video. I guess next one, it will talk about maybe we'll talk about the autocomplete design autocomplete system, or we could, let me check, we could talk about design YouTube, but I'm not sure which one route we will take. However, maybe you will know soon. So that's it for this video. I hope my description is quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in the future.